Today we are going to look at how you use sine rule to find the size of an angle in a non-right angled triangle. Okay, so we have our question here. 3 markers P, Q and R are placed at the corners of a triangular field. Calculate the size of angle RPQ. Okay, so first thing, as always, I'm going to label my triangle. So I have P here, and then directly opposite I have side P. I have Q here, and then directly opposite I have side Q. And then I have R here, and then directly opposite I have side R. So as I start this, my first initial step is going to be to write down my fractions, my sine rule fractions with the correct lettering. So I have P over sine P equals Q over sine Q equals R over sine R. Okay, and again, let's just fill in the information that we have. Okay, so we have side R, we have side P, we have angle R, and because we're looking for RPQ, it means we're looking for RPQ, so we're looking for this angle here. So we are in fact looking for sine P. So Q over sine Q is like it never happened. So now let's fill in the bits of information that we have. So P is 85, so we have 85 over sine P, because that's what we're looking for, and that's equal to R, which is 108, over sine R, so sine of 100. Okay, so far, nothing different here. However, now that we're at this stage, you are recognizing, hopefully, that your unknown is at the bottom of this fraction. That makes things just slightly more challenging for us. What we're going to do is just follow through on those same steps that we followed through on before. We don't want to be dealing with a division involving our variables, so I'm going to do something that's going to cancel that out. And I'm going to multiply both sides by sine P. By doing this, I can cancel sine P here, and then now sine P is going to appear here, and it's going to appear on the top of a fraction. So I'm going to have 108 times sine P over sine 100 equal to 85. Okay, so sine P is no longer on the bottom of a fraction, it is on the top, which is ideally what we want to be working with. Okay, so let me write that out again. So I had 108. There we go. 108 times sine P over sine 100 equal to 85. Okay, now when I start to think about what's happening to sine P, it is being multiplied by 108 and then being divided by sine 100. So if I want to undo a multiplication, I'm going to do a division. And if I want to undo a division, I'm going to do a multiplication. So I'm going to do this all in one step, and I'm going to say that I'm going to multiply by sine 100 over 108. And I'm going to multiply both sides by this. So sorry, I should have had 108 times sine P over sine 100, and that's equal to 85 times sine 100 over 108. Okay, so you can see now that multiplying by sine 100 and then dividing by it, it will cancel, and then dividing by 108 and then multiplying will cancel. So we end up with sine P is equal to 85 times sine 100 over 108. And if I put that in the calculator, I come out with 0.78 to 2 decimal places. Now, at this stage, do not reset your calculator, because we are now going to calculate P, because P is sine inverse of 0.78, which is 50.8 degrees. To give yourself the most accurate answer, do not reset your calculator between this stage and this stage. And that way you'll make sure that you are using the answer from the previous calculation rather than a rounded answer, which is going to make you just that slightly more inaccurate. Okay, right, let's take a look at a second example. So this time we have the diagram opposite, AB, represents a main road 28 kilometres long running due north. And AC and CB represent secondary roads. So think of this like the A9, and then this is like a bypass through like Eventon and Alness to come back out onto the A9. Okay, so we have to calculate the size of angle BAC. So BAC means that we are calculating this angle in here. Okay, so we are calculating angle A. So I'm going to label my triangle again. So this is side A, this is side B, and this is side C. And I'm going to write my formulas. And luckily, I don't have to change my formulas because they are in the same lettering as the original. So I have A over sine A equals B over sine B equals C over sine C. Okay, so what do I have? Well, I have A, and I have C, and I have angle C, and I'm trying to find angle A. So again, B never happened, and I'm working with A over sine A equals C over sine C. Okay, so that means I have 23 over sine A, because A is what we're looking for, equals 28 over sine 65. Okay, again, recognising that sine A is on the bottom here, and that is not what we want. So first thing I'm going to do is multiply by sine A. Okay, and then by doing this, I can cancel sine A from here, and it's now here. So I now have 28 times sine A over sine 65 equals 23. Okay, and then the same thing that I did last time, I'm going to multiply by sine 65 divided by 28 on both sides. And by doing that, this 28 will cancel here, and this sine 65 will cancel here. So I'll be left with sine A equals 23 times sine 65 all divided by 28. In the calculator, I will get sine A is equal to 0.74. And again, do not reset your calculator, because what we're going to do is we're going to get the angle A is sine inverse of this rounded 0.74. But if you put it in your calculator as it came out, then you will end up with the most accurate answer, which is 48.11 degrees.